Hey YouTube, welcome to Higher Math Solutions. This week's tutorial is going to go over how to graph and label parts of hyperbolas. A hyperbola is a type of conic. So if you have a three-dimensional cone and you take a plane and you slice it in specific ways, one of these shapes that you can get is what we call a hyperbola. There are two different hyperbolas that you can get. This form is in standard form and the x is being squared first and it's the positive, which means you get a hyperbola that is a horizontal hyperbola. But if it is switched around where the y term being squared is the positive term, then you get a vertical hyperbola, which looks like two parabolas that are facing away from each other. So it's like if you take an ellipse, but instead of an ellipse going towards each other, you take an ellipse and then you make them go away from each other, forming the hyperbola. You want the hyperbola to be in standard form, that way you can see all of its parts. You can see the center, which is the HK, and then you can determine the transverse axis and the conjugate axis from your A and your B, and then you can also determine your foci and your slant asymptotes that you get as well. So let's do an example. Okay. I have 3x squared minus 6x minus 2y squared minus 8y minus 11 equals 0. So this is a hyperbola. I can tell because I have two squared terms and one of them is negative. But this is not in our standard form, so we can't just look at it to get our parts. Make sure that you have your x terms grouped together as well as your y's. And we need to complete the square to be able to get it into the standard form. So to complete the square, you have to do it twice, one for the x squared and one for the y squared. And you cannot have a coefficient in front of x squared anything other than 1. So for the x terms, I have to take out this 3. So I'm going to factor out a 3. And I'm going to leave a little bit of space. And in these two terms, I'm going to factor out a negative 2. So this will be a positive 4. And again, I'm going to leave a little bit of space. And then the constant I'm going to add to the other side. So to be able to complete the square, you take the number in front of the x to the first power, and you're going to half it and then square it. So negative 2 halved is negative 1, and the negative 1 squared is a positive 1. And then you're going to do the same thing here. The number in front of the y to the first term. You're going to take the number and half it, which is 2. And then you're going to square it, and 2 squared is 4. Now you can't just start adding numbers to one side because that unbalances the equation. So whatever you do to one side, you need to make sure that you do to the other side as well. So I added not just a 1, but I added a 3 times 1. So I added a 3, so I need to make sure I add a 3 on the other side. And then over here, again, I did not add a 4, added a negative 2 times 4, so I need to subtract an 8. And now this is going to balance my equation. So in here, this is now a perfect square. This is going to become x minus 1 squared. And then this one will become y plus 2 squared. And then when you combine these numbers together, you will get a 6. Now to get it in standard form, there's one more thing we need to do. This number has to be a 1. And so I need to divide every single term by 6. So when I divide 3 over 6, I will end up getting a 1/2, which I'll put the 2 in the denominator. In this case, I will end up with a 1/3, which I will put the 3 in the denominator, and then the 6 over 6 is a 1. And this is your standard form, and this is going to be where we can look at it and be able to label and graph. Okay, so now that we're here, the easiest thing to spot is your center. So my center is at 1, negative 2. Since my x term is the positive term, it's going to end up being a horizontal parabola. My a and b come from the denominators. A squared is 2, so a is the square root of 2. And my b squared is 3, so b is square root of 3. And you need to know these because that tells you how far apart the hyperbolas are. So I can go ahead and start graphing it. I have the center at 1, negative 2. So here's my center. Also, since this is a horizontal hyperbola, this tells me the length that I go each way from the center. Root 2 is a little over 1, and so I'm going to go a little bit over 1 to the left, and then I'm going to go a little bit over 1 on the other direction as well. Those are what we call our vertices. And the vertices are what lay on what we call the transverse axis. So my vertices, since I changed the x coordinates, it's going to be 1 plus or minus root 2 and then negative 2. And I'm just going to leave it in the form of a radical because it's more exact. Also, I can go ahead and label my transverse axis or give the length. The transverse axis is the length from vertice to vertice. So you just double the a. So my transverse axis is 2 root 2. And your conjugate axis is the length that your asymptotes will go. So that is double the b term. So your conjugate axis is 2 root 3. Now the next thing that we need to be able to figure out are our slant asymptotes, because they form the hyperbola. Be able to do this, you're going to start with your point slope form. So you're going to do y minus the y value equals to something, which will be our slope, times x minus the x value. Now your slope will be a plus or minus, since you do have 2 of them. And to be able to figure it out, it's actually, once you have your a and b, it's not too hard. Since this is a horizontal one, your slope is going to be up b over a, because slope is rise over run. So it's just your b over a. If this was a vertical hyperbola, it would be a over b. That's how you would determine your slope. You are going to want to rationalize this. So if I multiply the top and bottom by root 2, I will get root 6 over 2. And then there are your 2 slant asymptotes. To be able to graph them, then you can make what we call a box. So I'm going to go ahead and put how up the b goes. So this tells me how up and down I go from the center. Root 3 is just a little bit under 2. So I'm going to put a little dot for there. And I'm going to make a box with my vertices and those points. And the slant asymptotes just go right through the corners. And they go through the corners and they go through your center. And then the reason that you need those is because the hyperbola will follow these asymptotes. So you start at the vertice, and then your hyperbola just follows those slant asymptotes, and so it forms your graph. Now there's only one more thing that we need to do, which is to graph the foci. The foci come from your C. Now to find the C, again, you need to know your A and B. So the formula to find C is a squared plus b squared equals c squared. So then you take your A and B and you square them. And you get 5 equals to c squared, so you get root 5 is equal to c. And then, so my foci points, you're going to end up with 2 of them. They're always inside of the parabola. So your foci points, again, it's going to change the x-coordinate. So it's just your x-coordinate plus or minus the c. And so this is what your foci is located on. And again, root 5 is a little bit more than 2, but you go from your center. So I'm going to go a little bit more than 2. And again, it should be inside of the parabola. And then those are your foci points. The only other thing that you might need to label is what we call the eccentricity. Hyperbolas have an eccentricity greater than 1. Ellipses have an eccentricity between 0 and 1. And circles have an eccentricity equal to 0. And so you should get a number greater than 1, but to find it, your eccentricity is just C over A. So now that you know your C, and now that you know your A, you just put one over the other, and in this case we do need to rationalize it to multiply the top and bottom by root 2. So we're going to get root 10 over 2. So there's your eccentricity. And so many times you have to label and write all these things down. So make sure that you have them nice and neat and in radical form. And then also you have all of your parts on the graph, including the foci. Thanks for watching Higher Math Solutions. See you next time.